Hey there, we're going to talk about density today. And we know the density is whether something sinks or floats, but it's more than just that. It's learning about the mass in a given volume and what the atoms and the molecules inside are actually doing within the object and how that affects its density. So let's go ahead and move on with our notes. So what is density? Density is defined as the amount of mass in a given volume. In other words, it's telling us how closely packed together something's atoms are. So here we have two blocks that are exactly the same volume. However, when we look at their masses, they're obviously going to be different. The molecules here, the atoms in this one, are packed closely together, and there are tons of them. Over here, there's very few of them. So obviously, there's a lot of space, which means this will have less mass than this. So less mass in the same given volume means this one over here is going to be less dense than this one, and this will be more dense. All right, so this one is more dense. So think about it like this. Think about the one with very few particles would be like this cup with marshmallows in it. All right, and that same cup, same volume, and this one would be the penny. So this is the one that's packed together. If I actually measure those out, which I did, the volume of both of these was 94 milliliters, or 94 centimeters cubed. All right. Now, if I find the mass of the marshmallows was 20 grams. When I divide that out, its density is 0.21 grams per centimeter cubed. It'll float. The pennies, like that big block there, its mass was 290 grams. When I divide the mass and the volume, I get 3.09 grams per centimeter cubed. It's going to sink. So therefore, right there we just proved this one's got more mass, therefore it's going to be more dense, all right, than the marshmallows. Now, if something is very dense, like the pennies, like we talked about here, its atoms are very close together. They're packed together tightly. Things like hammers, rocks, and bricks are objects that are very dense. If something is not very dense, like we talked about, these little marshmallows here, all right, there's a lot of air between them, so the molecules aren't packed together. The atoms are far apart. Things like sponges, balloons, marshmallows. So they're not going to be very dense at all. They're less dense. Now, you know we do calculating different things. We've done volume, regular shaped, irregular shaped objects. You know that I have certain steps that I want. Same with density. We have some steps to follow here. So when you do find density, you got to first find the volume, then you got to find the mass, then you divide. Density equals mass divided by volume. Here's an example problem right here. The mass of an object is 35 grams. Its volume is 7 centimeters cubed. What is the density? Use my steps to solve. We're trying to find d. We don't know what d is, so d equals question mark. Put in our equation. D equals m over v, which stands for mass divided by volume. Fill in what mass is. Mass is 35 grams. Volume is 7 centimeters cubed. Plug it into the equation. D equals 35 divided by 7. Now, show me your long math work over here. Actually divide out 35 divided by 7, and then circle your final answer, which would be 5 grams per centimeter cubed. Of course, it's mass per unit of volume, grams per centimeter cubed. That's how you do a math problem for me. Okay, so density also can be talked about in terms of liquids. We can determine a liquid's density just by mixing them with others. So if you pour together liquids that have different densities, they're going to form what's known as liquid layers. There's some example right there. The liquid with the highest or the greatest density will be on the bottom. The liquid with the lowest or the least amount of density will be floating on the top. Now, you've got to remember what the density of water is. We've been talking about it. Density of water is 1 gram per centimeter cubed. So if objects are put in with water and they float, that means their density is less than 1 gram per centimeter cubed. If objects are put into water and they sink, then their density is greater than 1 gram per centimeter cubed. Now, let's see how you guys do. Let's give you an example here. Here's some liquid layers. Let's try it. Just try it. All right. Here are the liquids that I'm going to give you. Here are their densities. All right. 15 grams per centimeter cubed, 3 grams per centimeter cubed, 7 grams per centimeter cubed. There's 10, there's 9, and 12 grams per centimeter cubed. I want you to match the colors with the correct densities based on what you just learned in the prior slide. All right, so I'll give you just a second here. Go ahead and pause the video and go ahead and label what you think the densities would be where they match. Green, white, red, blue, clear, and brown. Go ahead and pause. Fill in the answers. Okay, here we go. You should have put 3 grams per centimeter cubed there. It's the least dense, then 7 grams per centimeter cubed. Red becomes 9 grams per centimeter cubed. Blue is 10 grams per centimeter cubed. White, 12 grams per centimeter cubed. And then finally, the brown liquid is 15 grams per centimeter cubed. So most dense is definitely there on the bottom, and the least dense is at the top. Okay, that completes our notes for this section. See ya.